Hi guys, Sheshar here. Welcome to this new module. This module is about the virtual machines which we are going to create in the Azure cloud. So now that we have covered the two fundamental components of Azure IaaS, which is storage and network, now let's move to the real topic for which we did this preparation, that is Azure Compute. Now there will be a lot of other situations where Azure Compute may not be your target because you are using Azure Cloud just as a file share, or maybe you are using it for one of the platform like SQL, which is like a platform as a service where you don't need to create a virtual machine. But in a lot of cases, you will be creating the network and the storage so that you can create a Azure virtual machine. Now, Azure Compute refers to the virtual machine or computer which can be created in Azure Cloud. Like you have a variety of servers or laptops available in market today, similarly there is a wide variety of machines which are available on offer in Azure. Once again, we just pay for what we use. So you can get a machine for 1 hour per month or maybe for 744 hours. 744 hours is 24 hours a day and 31 days. So basically for the whole month. Use it when you need it and don't pay for it when you don't want it. It's as simple as that. This comes particularly useful when you have to do a batch job, which for your PC and server takes a lot of time to process. You can just spin up a really high quality machine and do the same job in 1/4 amount of time, or maybe even less than that. I'll give you a real example. All these videos which I shoot for you, once they have been like shot with the software which I use, the next thing which I have to do is I have to export them. And exporting the video takes a lot of time. I don't know what exactly happens in the background of the software, but the actual export of the video can take like a 1 hour video may take around 1.5 hours to get exported. It's that slow. Now it could be my computer as well. So what I do is I have spinned up another machine, and this machine is like a really powerful compute intensive F series machine. And when I have to export a video, I do the export of that video using that machine. So that machine takes almost 1/4 amount of time as compared to my own computer. So if my computer takes like 2 hours to export a video, that machine can do it in 30 minutes. And I only use it for those 30 minutes and then I turn it off. So something which could have taken a lot of time on my computer, I do it there really easily and I just pay for 30 minutes. So this is how you use Azure Compute for the smart things which you have to do and save your time. So here is what we are going to cover in this module. We are going to talk about the VM structure, like how exactly an Azure VM created. We are going to talk about the prerequisites before creating a VM. We are going to talk about the various options which are available for creation of a VM. Then we are going to talk about the virtual machine extensions. We are going to talk about the virtual machines availability sets. We are going to give you a demo of how to create a virtual machines and using all these options. Then I'll tell you what are your responsibilities when you host a VM in Azure and what does top versus deallocation of a VM means. Okay, so let's begin. Azure VM structure. Azure VM is same as a VM which you create with Hyper-V on your Windows server. So if you have created a Hyper-V, probably in the second week or third week, I asked you to set up a Hyper-V server and create virtual machines on it. So if you actually went ahead and did that, then this Azure VM is almost, or in fact, 100% same as what was happening there. Now, in that case, you went ahead and created the virtual machine yourself. Here, Azure creates the virtual machine for you. But other than that, this virtual machine is created the same way as it was created on your Hyper-V server. Now, based on the type of hardware that Microsoft has purchased, it has planned and defined what kind of machines can be provisioned on each server. So imagine if a developer, if a builder buys a piece of land, he's going to plan exactly where he's going to put the condos and where he's going to make the garden or the park, or where is he going to put the clubhouses. Basically, he's going to plan it so that he can maximize his profit and get the best value out of the land which he has purchased. Similarly, what Microsoft has done is whenever they create a server or whatever servers they create a complete plan. Like if we are buying this server has this kind of a hardware, then what kind of machines can be created on it. They cannot give you an open hand like you have on your own Hyper-V server, that you can choose the amount of RAM which you want, or you can choose the number of processors which you want to put on each machine. Because what you can do is that if I create a machine and you create a machine, you use your heart's desire, I use my heart's desire, what's going to end up is that the physical server which they have purchased for a certain amount of money, and they expected that they will be able to create say around 40 VMs on this physical server, suddenly you and I created some stupid VMs, and now they cannot create 40 VMs, they can only create 32 VMs on it, because we used some extra amount of storage or some extra amount of RAM from the server, and this has to like ruin the calculation which they had in their head. So that is why Azure doesn't give you an option to create custom machines. It only provides you predefined machines. Okay. Now this is a typical structure of a Azure virtual machine. This dotted line represents the resource group. This is the storage account which is created inside the resource group, and this is the virtual network which is created inside the resource group. This is the physical hardware or physical server which is in Azure data center, and this is a virtual machine and Hyper-V virtual machine which is getting created once again inside the resource group. Okay. Now, on this physical virtual machine, you have created quite a few virtual machines. If you go to those physical virtual machines, you will see that there is a D drive. And if you go inside the D drive of that machine, you will see there is a notepad file which says it is a temporary storage, and you should not put any uh, permanent data on it. The temp storage on your virtual machine is from a hard drive on the local server and not from storage. So typically in this case what is happening is that the C drive, the VHD file for this virtual machine, and if you created Hyper-V virtual machines on your PCs, then you will exactly understand what I mean by VHD drive. It is the hard drive of the virtual machine that is stored on a storage, on a NAS somewhere in a storage account. It is not locally stored on the physical server. Now, what happens is that although this storage is really fast, maybe it is connected on a fiber channel or a gigabit or a 10 gig connection, and it is providing a very good throughput and the machine is working all right. But there could be certain softwares which might be very picky about the slightest amount of latency which is there, because this machine is here and there is a network connectivity to the hard drive. And these softwares may want to put some logs or may want to put some temporary files on a hard drive which is local on this virtual machine. So when I say local, basically something which is inside this server itself. Maybe the server has say around 1 terabyte of hard drive, and you are planning let's say 50 virtual machines on it. So what you can do is that you can give all those 50 virtual machines a temporary storage of around 20-30 GB each in them, so that they can get a piece of a local storage from here, which is the fastest. So this is the temporary storage which Azure provide. Now, why is it a temporary storage? Imagine a situation where this virtual machine crashes, or you simply go ahead and turn off this virtual machine because you want to stop paying for it. Now typically what happens in those scenarios is when you turn off this virtual machine, the existence of this machine goes away. However, the hard drive is stored here and the network remains where it was. The next time when you boot it up, it may come back on this server, or there could be other servers in fact not there could be, there are various other servers in the Azure data center, and whichever can accommodate the machine, it will build up there, and then it will get connected to the same hard drive and to the same network. So as far as you are concerned as an end user, you will not notice the difference, because you will be seeing the same data and the same operating system and everything, and the virtual machine will be on another server now. So if last time the D drive was here, now the D drive, the temporary storage, will be on this server. So this is why the temporary storage keeps changing. And that's why they say that this storage is not permanent, and don't preserve any data on it, or don't put any data on it which you need later. It should be only used while the server is provisioned. So by the time the server is available here, this D drive will be available. But if you go ahead and deprovision the server, like you want to stop paying for this server, then the server will be removed and the storage will also be removed. Never store any permanent data on it. It can be lost in a lot of scenarios. So if there is a machine failure, so this machine got crashed and then Azure quickly fixed it and it came back up, it will probably come back here. Or maybe it's always possible that this physical server get crashed. And if this physical server got crashed, then this machine will probably crop up on another physical server. And this hard drive is lost entirely, right? So that's one of the reason because of which you can lose your D drive. Or maybe you simply wanted to stop paying for the machine, so you went ahead and deprovisioned the machine, and this machine got turned off. And now after a month, you wanted this machine back up, and you booted the machine. What happened? This machine cropped up on another physical server somewhere else. It did not come up on the same server. So again, you can lose your D drive. Or resizing. You created a D2 machine, but then you decided that I'm going to resize this machine. So you shut down this machine and you said resize. And when you resize it, maybe this server is only capable of making D2 machines, and now you resize it to be an F2 machine. So it's going to come up on a brand new server which can support F2 machines, and then it will have a D drive temporary storage on that server. So this is what I'm talking about, that the D drive is temporary and it can get lost. Never put any data on it. In fact, Microsoft put a notepad file inside it just to tell you the same thing. Prerequisites to Azure VM. Though Azure let you create a VM from the get-go, but it needs certain prerequisites before a VM is created. And when you don't create them, the Azure VM wizard actually creates them for you. But what Azure wizards create may not be appropriate for your plan. Hence, before creating your first VM, you need to ensure below components are in place. What are these components? Subscription. So, of course, you need to have a subscription in place. You need to sign up the trial or a pay-as-you-go or a partner account or a prepaid account. Whatever is your plan for your subscription, you need to have it in place. Second, you need to create a resource scope. So, where would a virtual machine come up? Like I showed you here, the virtual machine resides inside a resource group. If you didn't create this resource group, then where is this virtual machine going to stay? So what if you don't go ahead and create it, and if you just go ahead and use the wizard to create your virtual machine, what happens is that the wizard creates a brand new resource group for you every time you create a virtual machine. You need a storage account. Where is your hard drive going to stay? So now in case of managed hard drives, which is coming in the latest version of Azure, your hard drive is not like inside your Azure account, it is being stored somewhere else. So you should you really don't need to create this Azure account from this point of view, but ultimately this hard drive is going to be stored somewhere. And if you are creating an virtual machine with the unmanaged test, then in that case you need to create the Azure storage account where your hard drive can reside. Otherwise, once again, the wizard will keep creating a brand new storage account for you every time you run it. Virtual network or subnet on IP. So if you have a specific plan that this machine needs to get this IP address, then you need to plan that IP address. If this machine is part of a bigger deployment, you need to plan where in the network this is going to sit. And this virtual network should be available. Otherwise, what's going to happen? Every time you create a machine, it will create a brand new resource group. Inside that brand new resource group, it will create a brand new network, and it will create a brand new storage as well. And these machines will be entirely separate. In fact, I have seen that happening a lot of time. In this training itself, I saw initially that I didn't explain this concept and people were creating the virtual machine, and what used to happen was that they went ahead and create the first virtual machine. In the beginning of the second or the third week, I asked you to create your virtual machine. You went ahead and began with creation of a virtual machine. So you just followed the wizard and the virtual machine got created. While virtual machine was getting created, it created its own storage account and it created its own network, and then it also created a resource group where everything was residing. Now this was, let's say, the DC which they brought up. Now they create another virtual machine where they created the VM, and once again this VM followed by default the wizard creates a brand new storage account and it created a brand new network, and then it went into another resource group. So technically, if you try to ping, now this was supposed to be a domain controller and this was supposed to be a client machine, and you wanted to join this client machine to this domain controller, and when you are trying to do NS lookup or you are trying to ping the IP of this machine, they can't communicate to each other. They are trapped within the shell of their resource group, and in fact these networks are altogether different. If you have to make this communication go through, then you have to put some new technology to enable the communication between these two networks. It is possible. You can create some kind of a IPsec tunnel between them, a point-to-point tunnel between these network, or you can maybe do network peering is also a concept. But ideally, as far as Azure is concerned, this machine, this network, this whole thing is a separate deployment, and this is a separate deployment. This is not going to allow by default communication between them. So if you really want to do a proper deployment of multiple machines and they need to communicate to each other and all the application service and everything, then you honestly need to plan it. You need to create your resource group first, then you need to plan the storage inside your resource group, then you need to plan the network which is going to be there, then you need to plan the subnets which are going to be in this network, and then you go ahead and create your virtual machine, connect it there, and then create another virtual machine, connect it here to this subnet, create another virtual machine and connect it here. So you need these things before you can actually start creating the virtual machine. So these are the prerequisites of a Azure VM. Now Azure VM options. Azure offers predefined sizes of VM. Unlike your personal Hyper-V where you can choose and configure any size of VM, Azure wants to maximize the utilization of their hardware. Hence, they offer predefined sizes, but there are a lot of options. So you can find something that you like or something really close to it. Like I said, for Azure, it's like a builder. They have to maximize the utilization of their hardware resources, and hence they have told you that these are the predefined machines which you can create. But of course they offer you a lot of options, and you can you are sure to find something which you really like among all those options. There are multiple predefined sizes of VM based on processor, RAM, number of hard disk, amount of temporary storage, and number of NIC cards. So you can go to this link below, and this link talks about the specifications and sizes of the VM. So let's quickly have a look at it. So this is the article, and it talks about the various series of machines which are available, and these are the various Q families: extra small, small, extra small, A5 to A7, A8 to A11, then D series, then the V2 series of the D. So like I said, that usually V2 and V3 series will be same as the D series in terms of pricing. It's just that Microsoft would have launched a newer piece of hardware, a new piece of processor. So these will be faster options. So if you are getting an option to use a V2 or a V3 series, go ahead and use it. The E series machines are there, the G series machines are there. So this is the size table. This is the temporary storage which I was talking about, the D drive. Every machine get a D drive temporary storage. So this is the amount of temporary storage which is available. And there are various sizes, V2 series. All these sizes of machines are available, so you can definitely find something which you like. And even if you go to Azure and you go to let's say virtual machine, and you say that I want to create a virtual machine here, then here, yes, so this is where the sizes are available, and you can look here. They tell you the most commonly available sizes, the RAM, etc. You can find something from here, and here it is telling you the monthly cost for the machine, so you can see if it is in your budget. And these are not all the machines, so it's showing the popular machines earlier, and now when I clicked on see all machines, you can figure out what machine do you like. And We can also sort it by the price, so that you can make sure that you're not going beyond your budget, and within a limit you can stay and you can figure out which machine I want. Or maybe you want a really high RAM machine, so you can figure out, see, there are 218 GB of RAM. Wow. So 64 GB RAM, 56 GB RAM, you can figure out what you need. There are so many options available and the price is there. And then it also tells you the family. So depending on the work which you are trying to do, if you want a compute optimized machine, or if you want a general purpose machine, if you want a memory optimized machine. So if your work require more RAM and less processor, you can choose an options like this. If you need a machine which is like very high on processors, then you take a compute optimized machine. So things like that. You have got numerous options to choose your machine from. Azure supports various operating systems, so you can have Windows 7, 8, 8.1, Windows 10 as clients. You can have Windows Server from 2008 to 2019. You can have CentOS from 5.1 to 7. You can have Linux from 5.1 to 7. You can have Debian from 7 to 7.2. You can have Ubuntu from version 12 to version 14. All these operating systems are available. And you can also upload a custom image. If you have your own operating system image on which you have, let's say, installed the antivirus already, or you have it's a client machine, you have already installed the Microsoft Office and various other things. If you have already prepared an image like that, you can upload that image and you can use that for installation as well. So you have a lot of options in terms of operating system. Azure VM Extensions. Azure Virtual Machine Extensions are small applications that provide post-deployment configuration and automation tasks on Azure VM. For example, if a virtual machine requires a software installation or an antivirus protection, or to run a script inside of it, a VM extension can be used. Azure VM extension can be run with Azure CLI, PowerShell, Azure Resource Manager templates, and Azure Portal. Extensions can be bundled with new VM deployment or run against an existing system. To handle the extension on a VM, you need Azure Windows Agent installed, and some individual extensions have prerequisites such as access to a resource or dependency. Now, Azure VM extension is a small piece of software which you can use to provide a functionality to your virtual machine. Earlier, the virtual machine or the server for us was something in which we go inside it, we log in inside it, and then we do stuff on it. But now in terms of Azure, we have got two worlds. One world which look at all the infrastructure like this. For me, this is just a machine and I can have thousands of machines like this. And I could want to do some kind of an activity on these thousands of machine, and I don't have time to log into each of the machine individually and then go into that machine and start doing stuff. So what I can use is something which is called as Azure VM Extensions. And these extensions are small piece of softwares or maybe some scripts which on my command can go ahead and do a few things on the machine. So I can have an extension, and these extensions, I'm sure they will come as softwares by a lot of vendors in future, and there could be some very popular extension. I honestly don't remember some to tell you, or maybe I can just go ahead and Google popular extension for Azure VM. It's a custom script extension. You want to execute a script on the machine. Okay. Now I'm not getting some very good extension examples. Visual Studio Code as your extension. But basically, there is a lot of work which you want to. There could be probably a work which you want to do inside a machine. You have got two options. Either you can go and log inside that virtual machine and actually do that work yourself, or you can use some kind of a script or an automation to do that job for you. So this script and automation is called as a Azure VM extension, and you can configure these extensions here. Like this is a network watcher agent for Windows, so it looks at the network. Or you can have various. Okay, so we have extensions for Site 24/7, which is a monitoring engine. Or you can do Azure Pipelines extension. You can put a Puppet agent. Puppet is an automation. Or you can put a PowerShell desired state configuration agent. This is again an automation. We might talk about them in later sections, but these are really advanced things which I'm talking to you here. These extensions, the Puppet and the PowerShell desired state configuration and stuff like this. You may want to put a Microsoft anti-malware on the PC. So this is like an antivirus. So you can do this via the extensions. All right. So this is what extensions are. Now, in order for these extensions to run, the Azure VM agent is required. The Azure VM agent manages the interaction between an Azure VM and Azure Fabric controller. The VM agent is responsible for many functional aspects of deploying and managing Azure VMs, including running VM extension. So, an Azure VM agent is a piece of software which gets installed your Azure virtual machine, and it is a intermediary person between the Azure Fabric, which is this whole fabric, this Azure Fabric, and this virtual machine, which is actually an operating system running inside this shell of this name. So there has to be somebody who can do a coordination between the fabric and the virtual machine, and that's what is a VM agent. The Azure VM agent is pre-installed on Azure Marketplace images. So whatever images, so these are Azure Marketplace images. So all the, when you are trying to create a virtual machine, and these options which come to you for choosing the operating system, these are Azure Marketplace images. So it is, the Azure agent is pre-installed on Azure Marketplace images and can be installed manually on supported operating system. And the Azure VM agent for Windows is known as Windows Guest Agent. So the agent which installed on Windows Server is called as Windows Guest Agent. It is pre-installed in the images which are available from Azure, but if you brought in your custom image, then you have an option to put the software, the Windows Guest Agent or the Azure VM agent on the server, so that the functionalities like VM extension can be supported. So these are VM extensions, and you can do a lot of things with VM extension. Basically, remotely give a command, and that command will get executed inside the VM, and you won't even have to log into the VM. All right, so those are Azure VM extension. Let's talk about the availability sets in Azure virtual machines. A typical Azure data center will consist of numerous racks and numerous servers in each rack. So let me show you what is a rack. Typically, this is how a data center looks like. Okay, so this is a rack, or this is a rack, and inside this, servers like this are placed. Now, a typical data center looks like this. So there are numerous racks here, and inside each rack there are multiple servers or nodes. So a typical Azure data center consists of numerous racks and numerous servers in each rack. You get to choose a region while creating a virtual machine. So when you are creating a virtual machine, you do get an option to say where you want this virtual machine to be created. So you can say Australia East, Australia West, Japan, Korea, wherever, right? But you have no control on which node or rack your machine will get provisioned into. So you chose the region, but which node your machine will actually get provisioned into, you have no control on that. So if you have created 3 or 4 VMs for fault tolerance, let's say you created multiple domain controllers so that if one of the domain controller fails down, then at least another domain controller can help you. Or maybe you created 2 web servers and you put them behind a load balancer so that if web server 1 goes down, at least the web server 2 can process client's request. Now, because you didn't have any control on where they were hosted, let's assume they all end up on the same rack. So your one virtual machine went here, and your one other virtual machine went here, and the third virtual machine went here, and the fourth one went here, because you only chose the region and you wanted all of them to be in Australia East, and you went ahead. And incidentally, all 4 of them, they got placed on the same rack. And if this rack fail, it will defeat the purpose of your high availability. You created 3 or 4 VMs. You had no control where your VMs are going. They all went up on the same rack. And one silly boy went into the data center and he pulled off the cable, the power cable from that rack. Or some internet issue happened particularly for that rack. And the whole rack failed. This whole rack failed. What happened to your high availability? It went for a toss. Alright? Hence, you need to ensure that they get created on different racks. A whole rack can get down for 2 reasons. Hard failure known as a fault domain and periodic update reboot called as an update domain. Okay. So basically, now what you want is that when you create multiple domain controllers or multiple any high availability servers, you have to tell Azure in certain way that all these machines are alike, like they are a backup for each other. So you should not put them on the same server, same rack. You should put probably one here and the other one here and the third one in the floor above, or maybe, yeah, just don't put them in the same rack. And this process is called as actually creation of the availability group. When you create an availability group, which is a logical concept, and you add multiple servers as part of that availability group, then Azure knows that this is a domain controller availability group. That is, every machine inside this availability group is a domain controller. So that means I can't put all the machines, all these 4 machines or 5 machines on the same rack. I have to put them one here, other one here, and other one somewhere else in the same data center. Now a whole rack can get down because of 2 reasons. One, there is a hard failure. Somebody pulled the power off, or it got burnt, or something else happened. So there could be a hard failure. Or maybe there was a periodic update. So maybe they are doing a firmware update of this rack, or maybe they are doing some other work. So they are taking it down purposefully. Microsoft is aware of it. The hard failure is called as a fault domain. So in terms of availability group, we prevent ourselves from hard failure by becoming part of fault domain and from periodic update reboots through an update domain. Now let me show you. This basically makes a sense. Now this is a rack, this is a rack, and this is a rack. This is part of fault domain A because the whole rack will go down together. This is part of fault domain B, the whole rack will go down together. This is part of fault domain C because the whole rack will go down together. So as part of, let's say if you created 3 machines, what's going to happen is that one machine will get here, and this is availability set 1, availability set 1, and availability set 3, availability set 3, availability set 2, availability set 2. Okay, so these 2 machines are here. Let's say if there is a hard failure or a fault domain, this machine will go down, this machine will go down. But set 1 machine will remain available here and set 2 machine will remain available here. Alright. If there is a reboot because of a update, there was an update going on this rack and they rebooted the whole rack, then this server will go down here, but this server will remain available here. This server will go down here, but this server will remain available here. So they are kind of covering you in all scenario. And this is what is called as a availability group, which takes care of the fault as well as the scheduled updates, which is fault domain and update domain. That's what is a availability group. By creating availability set and adding multiple virtual machine to it, you ensure that all VMs are placed in separate racks and they do not reboot or fail together. So that's what is an availability set. Okay, finally, we are reaching to the demo. Choose the machine size. So we are going to say create a B2 machine. Machine resource group, I think we already have a resource group. Availability set, we are going to create one. Operating system, storage we already have. Network we have. Subnet we have. Load balancer we created one in the last module. Tags we have already created. Assign a static IP to the VM, monitoring and diagnostic. Okay, let's have a look and create an Azure VM. So we'll go here and we will go here and we first of all let's have a look at our resource group. So where is our resource group? Test resource group. What do you have in it? We have a public IP, we have a load balancer, and we have a resource group. So we have a network and we will have a subnet inside this network. Okay, so what we are going to do is I will go ahead and say let's go ahead and create an availability set. Test resource group, test AV set, and it's fault domain 2 and update domain 5. Use managed disk, yes align. Proximity placement group. So there is something which is called as proximity placement group as well. Let's say you were creating, where should I go? Okay, data center. So let's say you want them to be like on separate racks, but you want them to be close to each other as well. You don't want them to be really distant from each other. So you can create a proximity group and you can make sure that the machine remains close to each other too, despite of being in the separate fault domain or separate update domain. Tags, so person, once again, mark requested this to be created. Remember I put Sam name last time here and now Sam is also coming as an option here. Okay, so let's go ahead and create an availability group. Now we will go ahead and create a virtual machine. Once again, I'm going to choose my resource group, watch test VM and Australia East. Redundancy, I will go ahead and put availability set and test availability set. Of course, right now I'm creating just one VM, so it doesn't make any point to have an availability set, but you have to begin it the correct way. You create one VM and you put it in an availability set. Then next time when you, let's say that this VM is going to be a DC, and when you are promoting an ADC, you also put it in the same availability set, and you would want to name this availability set appropriately. Let's say you will say domain controller availability set. So whatever domain controllers you bring in, you put it in the same availability set. And you go ahead and say that you want a Windows Server 2012 and the machine size which you want is this one, and you provide a username. Provide a virtual machine. Now public inbound port. So this is the RDP. If you want to do an RDP to this virtual machine directly, then you need to allow this. What this is going to do is, first it will create a public IP for your for your virtual machine, and it will assign that public IP to the network card which this virtual machine will be creating in this during this wizard. And this will also create a rule in your network security group to allow RDP. For now, I will say none, or let's just allow it, so that this creates the so this step is not going to create the public IP, I reckon. I will see it in the next step. During the network, we will get an option. But what this is going to do is that it is going to allow RDP in the network security group. Desk, I will say standard, and networking. So virtual network is, so network is network test RG, and this is the IP which we are getting. Public IP, we are going to say none, and I'll tell you why. NIC network security group basic, public inbound port 3389, accelerated networking off, and load balancing yes. So I'm going to put this behind my load balancer, and my load balancer is the load balancer which I created yesterday. Now the problem is that yesterday I created a load balancer, but that was a basic load balancer, and I don't know what is the use of basic load balancer if it cannot even load balance a virtual machine, but I can't use a basic load balancer. What I'll have to do is that I will have to go here and go to load balancer, and I'll have to change this load balancer. I don't think I can change it, but I'll just see if it lets me. It's a basic one. I can't change it. So what I'm going to do is I'm going to delete this load balancer which I created yesterday, and I'm going to create a new load balancer. Test resource group, standard load balancer, and region Australia East, type public, standard, SKU standard, public IP use existing, and yesterday we created a public IP, so load balancer public IP. Okay, so I'll even have to create a new public IP, because once again the public IP SKU is basic and this load balancer need a standard public IP. So I would say standard public IP, and you should understand that I can create the public IP as a separate resource. It's just that the wizard here is giving me an option to create it along with. So availability zones, let's not go into the detail of that, and I'll just put one, and this is my load balancer. Next tag, who asked for it, person name, Mark. It's an optional thing, but I just keep doing it for you so that I can show you that what all Mark has created. So we go ahead and create a load balancer. So I'm not getting the load balancer option. I really wonder if this page can be refreshed, or I may have to start it from the beginning. What I'm going to do is I'm going to leave this option for now, and then from the load balancer side I will go ahead and add this machine. So anyways, so we allowed for the RDP port. This will allow it on the network security group, but we have not given a public IP to this machine because we are going to put it behind the load balancer. Management, you can enable boot diagnostic. Boot diagnostic gives you an option to have a look on the machine. then diagnostic information is stored in a separate storage account. So you can either use your existing storage account or you can create a new storage account. I'll just say that use the existing one. And identity, once again, read what this option is, that you can use identity from cloud or you can use Azure Active Directory. It's a preview feature so that you don't have to create your own Active Directory and you can log in via Azure Active Directory. Auto shutdown, this is very important feature. So like I said, that the virtual machines, they get built for the amount of time that you use them. So let's say that you know that every day during the work hours you are going to use it, and every day after the work hour you don't need it. So you can set a time, say around 7 p.m. or 8 p.m. What I do is that I always set a time of 9 or 10 p.m. in my virtual machine, so that even if I forget to shut them down, they get shut down by themselves. So you can say enable shutdown and you can provide it a time. And you can also send an email to yourself when you are shutting down the VM. Backup, so you can enable the backup as well if you want to, and the virtual machine will get backed up for you. These are the extensions, the VM extensions I told you about. If you want to install some kind of extension, then you can do that. VM generation Gen 1, Gen 2. So they tell you what Gen 2 supports, so you can choose Gen 2. Tag, once again, you can use person name, Mark. You can also say department. You can have n number of tags, like whatever you need to be. So what's happening here is that the RDP port is getting opened to the internet, whereas we wanted it to open from uh, the load balancer only. So we can make the change in the network security group. Anyways, we are going to go ahead and create the VM. And now we will go in our standard load balancer and we will go ahead and backend pool. And in the backend pool, we have to give it a name, load balancer, or just backend pool. And now it is going to ask that in what virtual network you want so we want it in the network, this one, and virtual machines. And you can add your virtual machine which you have just now created. And this virtual machine got added. This was the thing which I was trying to do from the Azure virtual machine, but now I have come on the other side of the things and I am adding it from the load balancer. So technically, I will just try to explain you what I am doing here. I will erase it. So what we did, this is our Azure cloud, okay, the whole thing. And this is our resource group inside the Azure cloud. We went ahead and created an Azure network, and we added a load balancer on this Azure network. And on the other side of load balancer, we gave it a public IP, the front end load balancer IP. And here we created a VM which is part of an availability set. Availability set is just a logical concept that when you add multiple virtual machines to the availability set, they will get placed in separate fault domain and update domains. Now, for now, I can't show availability set here because it's a logical concept. So you created a virtual machine, you have added it here. And you have told the backend pool or the backend IP of the load balancer that this virtual machine is part of it. So it is supposed to send the request here. Now what we have to do is that on this load balancer, we have to set up a rule that whenever a 3389 connection comes, send it to this virtual machine. All right. So allow RDP, and this is the name. Front end IP is the public IP of the load balancer. Service RDP, so that it selects the port number 3389. Protocol TCP. Target virtual machine, test VM. Network IP configuration, this is the IP. Port mapping, default. Okay, so this got created. Now what I will do is I will go to the virtual machine which we created. Let's see if it is running yet. So test VM, it's running, and I will go to the network card here, and I will go to the, yeah, so this is the network security group which is there, and it has RDP allowed from any source. So now technically speaking, we have the NSG network security group allowing it, and we have the load balancer. So if we go back to this diagram, everything is in place. Okay, now technically this was nothing. So this public IP is in place, the load balancer is placed, we have set up a rule to send it to the virtual machine here. So technically the RDP should work. Now what I'm going to do is, I'm going to try the RDP. How do I do it? I go to my load balancer and I look at the public IP of the load balancer. And what is the, okay, so this is the public IP, and then I go to the RDP client which I have, and then I go ahead and say add PC, and then I add the public IP, and then I say temp. I'm just giving it a name, temp PC behind load balancer. Okay, and I'd say ask for user account. Actually, this is the user account which I've used. I'm not going to do that. So I'll just say ask when required. I don't want to add another complication. So let's see what happens. So it is asking for the username. So I will go ahead and put the username which I created. That's it, guys. I just created a virtual machine. I put a load balancer in front of it. I created a rule, and now I am right in. So I hope you saw everything that we did. We chose a size, we created a resource group yesterday, we created an availability set, made the machine part of it, we chose an operating system 2012. Storage we didn't have to use because now Azure virtual machines are using managed disk, and in the managed disk actually Microsoft takes care of the disk, so you don't have to provide the storage account. Then we made it part of a network and a subnet, and we put a load balancer in front of it. Tags I already showed it to you, and assigning static IP to VM and monitoring and diagnostic. Okay, two more things which I want to show you, and they are, I'm going to shut down this machine. And guys, whenever you get this pop-up, if you want to allow the PC to be discovered over the network, then unless you are like really in an unsafe network of some kind where you can't allow your PC, or if you're in a public network, then say no to it. But in most other options, say yes to it, because allowing visibility over the network is going to help you a lot when you are working on different servers and different PCs, and basically as an IT administrator. And if you say no to it, then you will have to, at some point you will have to go inside in the settings of network connection, windows and all that, and from there you will have to allow the public viewing again. Because saying no to it is easy, but then the issues which in my experience have come up are very strange, that you will be trying to do something and other PCs will not be able to see it, or the discovery will not be working. It's just going to give you weird scenarios. So whenever you see this pop up, unless you are like in really a public network where you don't want other people to see you, to be able to see your PC, and by seeing your PC, nobody can just directly log into your PC. They still need the credentials, etc. Right? It's just that being available on the network. So if you really don't want to be available on the network, then say no to it. But in most cases where you are in a trusted network like your office or home or wherever, say always yes to it. Okay. So I was going to show you some of the options here in the virtual machine, the VM which we have created, test VM. And yeah, so basically the standard stuff comes up here, and you can have a look on your public IP here. This is the network you are part of, and this is the subnet which you are part of. You can always configure a DNS name. So a public IP, if it is not a static public IP, it will change whenever you shut down the machine. Actually, whenever you deprovision the machine, this IP will be lost, and when you boot up the next time, you will get a brand new IP address. So you may want to configure a DNS name so that you don't have to um, you don't have to keep changing the IP address in your RDP window every time. So what you can do is that you can give it some kind of a name, and instead of connecting the virtual machine with a public IP, you can connect it via a name. Okay, so that's there. And another thing which I wanted to show you was that if you ever want to give a public IP to your machine, or rather if you ever want to give a static IP to your machine, never ever go in the virtual machine inside and go to ncpa.cpl and go to the network connection card property and put a static IP there. Always come here, go to the network interface, and then go to IP configuration here. Then you go to IP configuration here, and then you change from here to static. And if you want to put a public IP on this machine, then you also go ahead and choose the public IP here. So you want to, so whatever changes you want to do on your machine, you come in the network card, NIC card properties, and then you do it. And if you want to create some kind of a firewall rules, etc., so you come into the network security group properties here, the NSG group. So this is the NSG which got created. Once again, the wizard created this for us, and these are the rules which are allowed. So you can go ahead and tweak the rules here. If I go ahead and delete this rule, then we will stop being able to RDP into the machine. So this is where you create the network security rules. So always give static IP on the NIC card level, never from inside the machine. This is the network security group. What else do I want to tell you? Monitoring and diagnostic. Okay. So you have got a standard monitoring console available here. You can look at various informations. You can set up alerts if the machine goes down, what you need to do, or an email can come to you, or if there is high processing going on in the machine, then if you want to take some action or if you want to be notified, you can create those alerts there. Then once again, there is a lot of report capabilities which are available, and you can look into them. You can get more acquainted with these things. It's a brand new machine, there is not much to show. Boot diagnostic is a good place where I want to come. So being an Azure virtual machine, we don't have a console access to the machine. There would be a situation where you are unable to RDP into the machine. The only way we connect to the machine right now is that we go to our RDP panel and we double click here and we connect to the machine and then we go inside. But what if we are not able to RDP and we don't know if the machine is on a blue screen or if the machine is sitting on an error? Then this boot diagnostic is the only way from where you can actually see the machine. Here it keeps an image of your machine current setup or the last known setup of the machine, and it is only stuck on this time as of now because I have already turned off the machine. So this is the last image of the machine which it has. So you always can come in boot diagnostic and have a look at the current position of your machine. Let's say you are rebooting the machine or updating the machine and machine is going down. As soon as the machine got locked off, you lost the connection. Now how do you look at the machine? You can come into boot diagnostic and keep refreshing this and you will see this will keep changing. This is not live, but you get update in every couple of seconds. So that's good enough. If you ever face an issue where the machine is not reachable or something has gone wrong with it and it's not working, one of the things which you can do is you can redeploy the machine. So right now the machine is turned off, so it can't do that. But basically what redeploy does is that, like I showed to you, that a virtual machine is ultimately a machine which is created uh, like this, and when you redeploy it, it will get deleted from here and it will be hosted on another Azure Hyper-V server, and it will be a brand new machine connect to the same storage and same network. So you can do the redeployment of the machine. So that's one option, redeployment. You also have this connection troubleshooter. So if you're unable to connect to the machine for some reason, you can use this window connection troubleshooter. It helps you or at least points you in the right direction. And of course, you have got, like every other resource, you have got a support request option. So if you are unable to do something or if you need help, then you can log a support request and Microsoft can help you. You also get advisor recommendations. So Microsoft advisor always run and help you to identify if there is some changes which you can make to your infrastructure to make it more efficient, secure. So you can always look at the advisor recommendation. So yeah, here is the disk of your virtual machine, the disk which got created for this VM. So this is the disk and this is being hosted by Microsoft. So we have no clues where this disk is. And yeah, that's the size of your virtual machine, and you can go ahead and resize your virtual machine. So if you decide that you want to, let's say that we did a B2S machine, but a B2S machine is not sufficient for us, and now we decide that we want a better machine, so we can go ahead and say choose this, and we can say resize, and already our machine is like in a shutdown situation, and what's going to happen is that this virtual machine will be brought up on a brand new server where it supports the D8 configuration, and we will get more better configurations, and we can do it for a small amount of time or we can do it for a long amount of time. Like the pizza shop can usually run a B1S machine, but on every Friday they can get upgraded to D8S machine, and then on every Monday they can go back to B1S machine. So that's what is size, and you have an option to resize the machine. Going back to the training. So, all right, so that was your Azure VM demo. Now, your management responsibilities. Azure VM is a infrastructure as service offering. Azure is only responsible for the underlying infrastructure, the hardware or the services available to you. So Azure will take care of the physical hardware, Azure will take care of the network, Azure will make sure that your public IP remain available, Azure will make sure that your network speeds are good, Azure will make sure that the physical hardware of the rack remains in good state. But the below components will remain your responsibility. So once you have made your VM, any data which is inside that VM is your responsibility to maintain. I know the server is in cloud and you expect that it is always going to remain available, but guys, that's why they offer you availability sets. That's why they ask you to do the backup, because Microsoft is good, but Microsoft is not God. A machine can crash, and if a machine crashes, then Microsoft do not have a responsibility of backup of your data. They will get the machine back up for you, But if the data gets corrupted or if something happens wrong to it, then you need to make sure that you have an appropriate backup which you can restore. So that's what is data. OS and updates. You have installed a Windows operating system or a Linux operating system. So if you want to go ahead and perform the updates, it's going to be your responsibility. Microsoft will not do. However, you can always install some extensions. Using them, you can create an automated schedule to perform updates. But whatever it is going to be your responsibility, not Microsoft responsibility. Any application installed inside Azure Virtual Machine is your responsibility, not Microsoft responsibility. And once again, anything else which you can think of inside the Azure VM, as soon as you go inside, it's your VM. So let's imagine that you are living in a building and your house is in a building and you have a flat. There are multiple floors and there is whole reception and everything. And this whole reception, the overall building and everything is maintained by the developer. The corridors and everything is maintained by the developer. The whole building is reinforced and kept in a good condition by the developer. But as soon as you open the door of your house and you get inside your flat, then it is your responsibility to maintain a clean flat. The developer is not going to come inside your house and clean your bed. So this is your bed and you need to make it, right? Now, this is one of the most important concept which I want to tell you about, the stopped versus deallocated. A virtual machine is hosted in an Azure host. So I told you that a physical server hosts your Azure VM. When you turn off a VM or shut down a VM, it is still on the same host. You still retain the public IP if any, and you continue to bear the cost. Let me show you. Let me go here. Do you see? My virtual machine is stopped deallocated. Your virtual machine, the one which we created just now, is still stopped. Why it is stopped? Because I didn't stop it from here. I just went ahead and shut it down from within the operating system. This virtual machine is still owning this public IP address. So it is paying for this public IP address. This virtual machine still is on the same virtual server, physical server, wherever it got hosted. So if I go back to this image, the virtual machine is still there. The operating system is shut down, but the virtual machine is not deleted. So it is still keeping and hold on the resources inside this physical server. So you have yet not stopped paying for the virtual machine. If you really want to stop paying for the virtual machine, once you have shut down the machine, you have to come here and stop it. And once it is stopped, you will see it will say stopped deallocated. So right now it is deallocating. It is important that the machine should get deallocated. Then you will only pay for the hard drive which will remain in the storage and it is cheap. And the compute part of the machine, you will stop paying for it. Okay. When you deallocate the machine, that is stop using the Azure console or app, then the machine is completely removed from the host and only VHD of the machine is preserved. So when the machine is removed from the host and the VHD is reserved, then you will pay for the VHD. And then you stop paying for the VM price. However, the storage cost will be still borne by you. Once again, even when the machine gets removed from here, this hard drive will still remove in the storage and you will still keep paying for this hard drive. Okay, so let's make sure that our machine is deallocated. Hopefully it is. Yep, it's deallocated. All right. All right, guys, so this is the end of this module. I told you how, what is the structure of the VM, the temporary disk, the storage in which your VHD is there, and how virtual machine pop up on a Hyper-V server, and then when you resize it, it can pop up on another Hyper-V server. So I explained all that to you. I told you the prerequisites like the resource group, the subscription, the storage, and the network, which should be there before you create a VM. We had a look at various virtual machine sizes options which are available. Told you what is a VM extension, and then we also told you how to create an availability set. I gave you a demo of doing all these things. Then I told you that inside the VM, it's all your responsibility, and outside the VM, it is all Azure's responsibility. And then last, but one of the most important thing, always deallocate your machine when you want to stop paying for it. Just shutting it down does not get you away from your responsibility. So here are your action items. Create a VM availability group. I already did it, you can do that. Create your first VM as a part of that availability group. Give your VM a private IP, but allow RDP on it, or otherwise you can not allow RDP on it, and then you can later go into the network security group and add that allow rule yourself of RDP. Go back to the load balancer which you have created, and remember, if you also created a basic load balancer, you will have to change it to a standard load balancer with a standard IP, and add this virtual machine to the backend pool. Create a rule on the load balancer to allow RDP to your virtual machine. You can do that. Create a rule in the network security group associated with your virtual machine to allow RDP. So if you chose RDP to be allowed while creating the VM, this rule would have been already created, but I suggest you don't create it. In fact, go to the NSG and create it yourself. And then ensure RDP is working from your public IP. If you do this, you would have gone through a entire chain of creating an infrastructure from the network point of view, from the storage point of view, from the load balancer point of view. It's pretty cool if you are able to do this whole practical, and it's quite easy. Okay, so that's it for this module, and I'm going to talk to you in the next module soon. Thank you.